So in the last lesson, I briefly talked about containers. A container is an isolated environment for running an application. Now, one of the questions that often comes up is, how are containers different from virtual machines or VMs? Do you know the differences? Well, a virtual machine, as the name implies, is an abstraction of a machine or physical hardware. So we can run several virtual machines on a real physical machine. For example, we can have a Mac, and on this Mac, we can run two virtual machines, one running Windows, the other running Linux. How do we do that? Using a tool called hypervisor. I know, it's one of those computer science names. In simple terms, a hypervisor is software we use to create and manage virtual machines. There are many hypervisors available out there like VirtualBox and VMware, which are cross-platform, so they can run on Windows, macOS, and Linux, and Hyper-V, which is only for Windows. So with a hypervisor, we can manage virtual machines. Now, what is the benefit of building virtual machines? Well, for us software developers, we can run an application in isolation inside a virtual machine. So on the same physical machine, we can have two different virtual machines, each running a completely different application, and each application has the exact dependencies it needs. So application 1 may use Node version 14 and MongoDB version 4, while application 2 may use Node version 9 and MongoDB version 3. All these are running on the same machine, but in different isolated environments. That's one of the benefits of virtual machines. But there are a number of problems with this model. Each virtual machine needs a full copy of an operating system that needs to be licensed, patched, and monitored. And that's why these virtual machines are slow to start, because the entire operating system has to be loaded, just like starting your computer. Another problem is that these virtual machines are resource intensive because each virtual machine takes a slice of the actual physical hardware resources, like CPU, memory, and disk space. So if you have 8 gigabytes of memory, that memory has to be divided between different virtual machines. Of course, we can decide how much memory to allocate to each virtual machine, but at the end of the day, we have a limit in terms of the number of VMs we can run on a machine. Usually a handful, otherwise we're going to run out of hardware resources. Now let's talk about containers. Containers give us the same kind of isolation, so we can run multiple applications in isolation, but they're more lightweight. They don't need a full operating system. In fact, all containers on a single machine share the operating system of the host. So that means we need to license, patch, and monitor a single operating system. Also, because the operating system has already started on the host, a container can start up pretty quickly, usually in a second, sometimes less. And also, these containers don't need a slice of the hardware resources on the host. So we don't need to give them a specific number of CPU cores or a slice of memory or disk space. So on a single host, we can run tens or even hundreds of containers side by side. So these are the differences between containers and virtual machines.